As an operator, you're responsible for monitoring pumps in your facility. This involves making routine checks to make sure that they're operating normally and efficiently. Making these routine checks is a good way to help avoid costly and unnecessary shutdowns. With experience, you'll be able to tell right away when a pump is not working properly. Before you go out to inspect any pump, you should know how the pump normally operates. That includes knowing the pump's normal flow rates, operating temperature, and its normal suction and discharge pressures. You should also learn about any special features the pump has and what type of liquid it pumps. In addition, it's a good idea to become familiar with the pump's operating history. It will help you identify any recurring problems with the pump and may make troubleshooting a problem easier. Pumps can experience a variety of problems, and each problem can have a variety of symptoms. In spite of that, there are some general types of operating checks that can be made on all pumps. These basic operating checks relate to 3 of your senses. The checks involve looking, listening, and feeling for symptoms of pump problems. Looking for symptoms of problems often starts with instrumentation for the pump. As an operator, your main concern in determining a pump's performance is whether or not the pump is supplying the correct pressure and flow. Improper pressure or flow readings could be caused by a variety of problems. Some deal with the process fluid, and others are more mechanical in nature. Take some time now to learn more about the causes of improper pressure or flow. An abnormal change in pressure or flow can occur relatively suddenly, or it can be very gradual. If instrumentation shows a slow, gradual decrease in flow or pressure, it could be a sign that the pump's internal parts have worn, or that a condition is getting worse. So it's important to be alert to even subtle changes in instrumentation readings that may indicate a problem. In addition to looking at instrumentation, the pump itself should be checked for symptoms of problems. For example, operators should check for overheating by feeling the pump and motor casings and the bearings to get an indication of their temperatures. However, this must be done carefully because overheated components could cause burns. When more precise temperature readings are required, it's usually necessary to use a temperature instrument, such as a pyrometer, to monitor equipment temperatures. In addition, some pumps have indicators for bearing and lube oil temperatures. An increase in temperature could mean there's a problem with the lube oil supply, which is causing the bearing to overheat. This pump is running normally. The operator knows from experience that the pump sounds the way it should. Symptoms that indicate problems include excessive noise or unusual sounds. Some problems have their own distinctive sound. For example, a loud rattling or clanging sound could be caused by a broken pump part or a foreign object loose inside the casing. A howling or growling sound usually indicates worn or damaged bearings. It usually means that there's a lubrication problem. A high-pitched screeching is commonly produced by metal-to-metal contact between rotating and stationary parts. It could also indicate a lubrication problem or improper alignment or clearances between parts. While some problems have distinctive sounds, others simply produce excessive noise or vibration. Checking for unusual vibration is a common part of a pump inspection. A quick check can usually be accomplished by carefully touching the motor and the pump with a bare hand. For a more detailed examination of vibration, vibration detection instruments can be used. These instruments are extremely sensitive and collect various types of data on the nature of the vibration. After the data is collected, it can be analyzed to determine if problems exist in a pump or its driver. So far, we've been discussing some general symptoms of abnormal pump operation. Although we looked at each one separately, many symptoms are related. When you detect one symptom, be sure to look for others that could help narrow down the cause of the problem. Let's pause here to give you a chance to check your understanding of symptoms of pump problems. Checking for leaks is a routine part of inspecting pumps and their related equipment. Here, the operator begins with the suction piping, checking the suction valve packing and gasket for process liquid leaks. Then he turns his attention to the pump itself. Pumps that use packing often need a small amount of leak-off to cool and lubricate the packing. A trickle of liquid is normal. Unlike packing, mechanical seals should not have a noticeable leak-off. If liquid is leaking from a mechanical seal, the seal has failed and action should be taken to have the pump repaired. After checking packing or seals, the operator looks over the rest of the pump. Here, he checks the bearings to see if there are any oil leaks. Finally, he looks over the pump's discharge piping for the same things as with the suction piping. If he finds a leak, he'll trace it to its source and then report it to his supervisor. When you hear a rattling noise that sounds like marbles rattling around inside the pump, it's usually a sign of cavitation. Other signs of cavitation include fluctuations in discharge pressure and sometimes an overheated pump casing. Cavitation can also cause a decrease in flow. The extent to which flow decreases depends on how bad the cavitation is. Cavitation is usually violent, and if it's not corrected, the pump can be damaged. To stop or minimize cavitation, the suction head must be raised above the minimum net positive suction head for the pump. Sometimes this can be done by cutting back the flow on the discharge side of the pump. Restricting the flow of the fluid as it leaves the pump basically increases the pressure in the pump. Increasing the pressure will help keep the fluid from boiling and causing cavitation damage. However, restricting discharge flow could affect processes in the plant. So it's normally done temporarily if plant procedures allow it until other actions can be taken to stop the cavitation. In some cases, cavitation can occur because the temperature of the process fluid is too high. This causes the fluid to boil when it experiences the drop in pressure as it enters the pump. In this case, the temperature must be lowered to eliminate the cavitation. In this topic, we saw how important routine inspections can be in locating problems that could cause damage to the pumps in your facility. Experience with your facility's equipment and knowledge of the basic operating conditions for each pump will help you to recognize when something's wrong with the pump. It's then your job to report problems to your supervisor. Take a moment now and try some practice questions. Unlike packing, mechanical seals should not have a noticeable leak-off. If liquid is leaking from a mechanical seal, the seal has failed and action should be taken to have the pump repaired. Cavitation is usually violent, and if it's not corrected, the pump can be damaged. To stop or minimize cavitation, the suction head must be raised above the minimum net positive suction head for the pump. Sometimes this can be done by cutting back the flow on the discharge side of the pump. Restricting the flow of the fluid as it leaves the pump basically increases the pressure in the pump. Increasing the pressure will help keep the fluid from boiling and causing cavitation damage. However, restricting discharge flow could affect processes in the plant. So it's normally done temporarily if plant procedures allow it until other actions can be taken to stop the cavitation. In some cases, cavitation can occur because the temperature of the process fluid is too high. This causes the fluid to boil when it experiences the drop in pressure as it enters the pump. In this case, the temperature must be lowered to eliminate the cavitation.